We've solved systems of 3 in a previous lesson, and this is an example of where we can use matrices to actually solve a system. So we take those variables out and we're left with just the coefficients and the numerical values, and it sometimes makes things a little less complicated when you know how to work with matrices. So we're first going to talk about the coefficient matrix. The coefficient matrix is going to be a matrix that has all of the coefficients. So you can see I'm kind of highlighting nothing in the first equation and the second equation. So I'll show you why I'm highlighting nothing. I have 1x plus 0y plus 1z equals -2. That's the first equation. So when I write my coefficient matrix, across row 1, I'm going to have 1, 0, 1. This is x, y, and z. X, y, and z. Column 1 is the x's, column 2 is the y's, and column 3 is the z's. Notice how the constant is not included. In the second equation, we've got -3x plus 2y plus 0z equals 17. So our coefficient matrix row 2 is -3, 2, 0. And in our last equation, we have 1x minus 1y minus 1z equals -9. So row 3 is 1, -1, -1. Now the augmented matrix is a combination of the coefficient matrix and the constant. So I'm going to put a little bar here. So here's our constant. Now the constant is on the opposite side of the equal sign. We're still going to have x, y, and z columns. Row 1 is 1, 0, 1, and then our constant that is equal to is -2. -3, 2, 0 equals 17. 1x minus 1y minus 1z equals -9. And that's the augmented matrix. We're going to work with the augmented matrix to solve these systems using row reduction operations. And we actually used row reduction operations in our previous lessons by hand when we were solving systems, but we did it in a way that was extremely I want to say that it wasn't extremely obvious what we were doing, so I'm going to show you what it was that we did, and we're going to use our calculators to do that. We're going to solve this system using an augmented matrix and row reduction operations. So the first step is to create the augmented matrix. So across the first row, I've got 3, -1, 2, and then that's my equal sign, 0. 2x, 3y, 8z equals 8. Remember our columns, x, y, z. 3x, -1y, 2z, 2x, 3y, 8z. 1x plus 1y plus 6z equals 0. And there's our augmented matrix. Our second step, step 2, is to enter the matrix into the calculator. So enter this matrix into the calculator. So I'll show you how to do that. Turn our calculator on. We go to number 1. See how it says run matrix? Number 1, run matrix. And I'm going to delete this so you can't see what I've done there. And then you're going to go to F3. See how it says matrix right there? F3. And we're going to select matrix A. Now, if I delete this, that's what yours should look like. If yours had values in there, you just hit delete and then it'll go back to none. So we're going to select matrix A. So I'm going to press enter and it says, what's your dimension? Well, remember my dimension was 3 rows by 4 columns. So 3 by 4. Then press enter. and it's going to take me in and allow me to enter in the values that I have written down on paper. So it was 3, enter, -1, enter, 2, enter, 0, enter. The next row is 2, 3, 8, 8. And the next is 1, 1, 6, 0. Feel free to stop this video, rewind it, watch it as many times as you need to get the keystrokes that I've done here. Now I'm going to hit exit. And you can see it says a 3x4. If I press enter, there it is. It's right there. So I'm going to press exit again and exit again. Now when I hit option, I hit MAT and I hit F6. So I'm going to go back here. I hit option and then I'm going to hit MAT, F2, and then I'm going to hit F6. And do you see this right here? RREF, reduced row echelon form. I'm going to press that. Now I'm going to tell it matrix A. So you can see on number 2 it says MAT. So I'm going to hit shift, number 2, and look at what it brought up there, MAT for matrix. And then alpha A, because it was matrix A that I entered the data in. And then I press enter and look at what it did. Now, let me show you the matrix. Shift 2, alpha A. There's the original matrix that we entered. When I did reduced row echelon form, look at what it did. 1x, 0y, 0z. So 1x equals 2. X equals 2. 0x, 1y, 0z. So 1y equals 4. And you guessed it, 1z equals -1. 2, 4, -1. That saved us a whole heck of a lot of time, didn't it? It sure did. That saved us a whole heck of a lot of time. So the answer to this is simply 2, 4, -1 as an ordered triple. Done. So we enter matrix into the calculator. Then we choose RREF, matrix, and then whatever the name is, whichever name, whichever matrix you entered the data in. Now you don't need me to write down the steps because you can go back through and watch the video again and see all the steps that I hit to get to the answer. All the steps that I hit to get to the answer.